Logarithmic differentiation. The calculation of derivatives of complicated functions involving products, quotients, or powers can often be simplified by taking logarithms. The method used in this following example is called logarithmic differentiation. So for example 7, we're going to use logarithmic differentiation to differentiate y, which is equal x to the power of 3/4 times the square root of x squared plus 1 over 3x plus 2 to the 5th power. So first, let's write this out. We have y, which is equal to x to the 3/4 times the square root of x squared plus 1 over 3x plus 2 to the 5th power. So what we're going to do is we're going to take the natural log of both sides before we even differentiate. So we're going to take the natural log on this side, so the natural log of y, times the natural log of this side. So we have the natural log of x to the 3/4 times the square root of x squared plus 1 all over 3x plus 2 to the 5th power. Okay, so now on the left side we still have the natural log of y, and then what we're going to do is we're going to use the laws of logarithm here. So we have in the numerator, in the numerator for our function, it's going to be the natural log of x to the 3/4 times the square root of x squared plus 1, and then it's going to be minus the natural log of 3x plus 2 to the 5th power. Okay, and now since we have two items here that we're multiplying, then we can expand this with addition. So we have the natural log of y, which is equal to the natural log of x to the 3/4 plus the natural log of, well, we're going to write this now as x squared plus 1 to the power of 1/2, since that's the same thing as the square root of x squared plus 1, and then minus the natural log of 3x plus 2 to the 5th power. Okay, and now we're going to use the power rule for the logarithms. So we have the natural log of y, which is equal to 3/4 times the natural log of x plus 1/2 times the natural log of x squared plus 1 minus 5 times the natural log of 3x plus 2. Okay, so now what we want to do is we want to take the derivative. So now that we have this all set up, now we're going to differentiate. And we're going to differentiate implicitly. Okay, so we're going to take the derivative with respect to x of the natural log of y, and then we're going to take the derivative with respect to x of each function. So we have the derivative with respect to x of 3/4 times the natural log of x plus the derivative with respect to x of 1/2 times the natural log of x squared plus 1 minus the derivative with respect to x of 5 times the natural log of 3x plus 2. Okay, so when we take the derivative on the left side, the derivative of the natural log of y is going to be 1 over y times y prime. And that's going to equal 3/4 times 1 over x times the derivative with respect to x of x plus 1/2 times 1 over x squared plus 1 times the derivative with respect to x of x squared plus 1 minus 5 times 1 over 3x plus 2 times the derivative with respect to x of 3x plus 2. So, in our next step, we have 1 over y times y prime. And so we end up getting 3/4 times 1 over x times the derivative of x, which is 1, plus 1/2 times 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x, minus 5 over 1 times 1 over 3x plus 2 times the derivative with respect to x of 3x plus 2, which is 3. And now let's write these the right side. So we have 3 in the numerator, so this is 3 over 4x plus, if we take a look at this 2 before we multiply, we can simplify the 2. So what's remaining is x over x squared plus 1. And then minus 5 times 1 times 3 is 15 over 3x plus 2. Okay. Now we're almost done, but we're not quite done because we still need to solve for y prime. In order to solve for y prime, we need to multiply both sides by the value of y. So if we multiply both sides by y, so we end up with y prime, and that's going to equal y times 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. And notice that these y's become 1. Okay, so we're almost done, not quite. Okay, we need to come back up here, right? And what do we know that y equals? Well, let me bring this down here. Well, from our original problem, right, we know that y is equal to this. So that means that we need to replace this y with what it's equal to. And what it's equal to is this entire function from the beginning. So let's go ahead and finish our problem. One more step. So our final answer is going to be y prime, which is equal to, we have x to the 3/4 times the square root of x squared plus 1 divided by 3x plus 2 to the 5th power, since that's what y equals, and then multiply that by 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. And there is the derivative of our function.